Hey everyone, welcome to another session of CeerazzleDazzle Physics. In today's session, we're going to be talking about labelling forces and friction. So we'll start off with the following. We've got a book resting on a table here. Let's say you're asked to label the forces acting upon the book. Well, we know that the weight will be acting downwards, so I can use an arrow to represent the force. So here we go. The weight is going down here. But obviously that's not the only force acting upon the book. There's also a force pushing up. That's going to be the reaction force. This is the reaction force. There must be the reaction force, otherwise the book would just move down. So with labelling the weight going down, the reaction force is acting upwards. This is if the object is on a solid surface. So if it's on a solid surface, weight's going down, reaction force is going up. Right, let's scroll down for the next diagram. So, what exactly is friction? Friction is the opposition to motion, so it's the force which opposes motion. So let's say in this example we've got this car which is moving to the left. This is the thrust. So it's moving in this direction, so the force is the thrust in that direction. Where is friction going to act? It's going to act in the opposite direction to the motion, so the friction acts in this direction. So this is the friction. So the friction is always in the opposite direction to motion. So if you're moving in one direction, friction acts in the opposite direction. Right, we can label other forces, which we just did in the previous example. We know that the weight is still going down. Here is the weight. And upwards we have still the reaction force. This is the reaction force. Yeah, because you're assuming that obviously the car is on a solid surface. Yeah, so this is a solid surface. Nice. Okay, what about if the object is in water? So we've got the ship here. Let's label the forces acting upon the ship. We still know that the weight is going down. Yeah, and the boat's trying to move in this direction. So this is the thrust or driving force. You might see in books, they might say driving force in that direction. So which way is the friction acting? It's going to oppose the motion. It's acting in this direction. Here's the friction. But now, there's a force which obviously stops the ship from moving down, and it's going to be pushing upwards here. So the force pushing upwards, this force is going to be the up thrust. Notice it's not the reaction force. Why? Because it's on a liquid, so we're in liquid. So this is a liquid, that's the reason why. So up thrust is the force pushing you upwards if you're on a liquid. So that's the up thrust. Right, so let's scroll down. What about another example? What about if we're falling in the air? So if you're falling in the air, so here we have a parachutist, parachuter. He jumps out of the plane, and we know that the weight will bring him down. But what other force is acting as he falls down? He also has a bit of air resistance. So we've got different forces now. So look, when he's falling through the air, he has air resistance. That's like the friction. That's what's trying to stop him from moving downwards. So air resistance in this case, this is like, whoops, the friction. Okay, there we go. So, summary. We can represent forces using arrows. The length of the arrow tells me the size of the force. So the greater length of the arrow, the greater the size of the force. The reaction force acts upwards upon objects on solid surfaces. And then we also have the friction always acts in the opposite direction to motion. And then the upwards force when you're on a liquid is going to be the up thrust. And when you're falling through air, we have air resistance, which is also pushing upwards. So that's it for today's session. I shall see you next time for more CeerazzleDazzle Physics. Goodbye.